Assalamu alaikum, dear students. I hope you are fine, doing well. Well, this time I again meet the students who are following my videos on vector calculus. It is lecture number 4th that I want to deliver on this vector calculus. I have already told you that we have started this from middle when I took lecture number 1. In lecture number 1 I told you there that we have already completed some lectures before lecture number 1. That is why we took the this gradient divergence product formulae we took there. But before product formulae there are some lectures that we already completed. Some students were asking me about those lectures. No problem, I will later on make some videos on that also. I will name those vector videos some other name. I will share with those lectures with you later on. But we have to go ahead because keeping in view the pandemic and the time that college students who are following my videos, they require this with a fast speed because they have to appear in examinations, so on. Now today my lecture is on second order differential operators. We did differential operator, we started from the del operator, which is also called nabla operator. We did the properties of that. Now we come to second order differential operators. You see, I will again start with this del operator. This del operator, this del operator, which is I dou by dou x 3d j. In case of 3d we take this j unit vector del by del y plus k unit vector k del by del z. What is actually now this del? This implies del has, it is vectorial character. Remember this, the operator del that we introduced, that we defined it before from starting lectures, that del we defined. This del has actually it is own the vectorial character. Remember this, I am just repeating it again. Next, if phi is scalar point function, we started with phi, let it be scalar point function. Then you found in previous lectures gradient of phi. What is gradient of phi? Does gradient of phi remain scalar? Does it remain scalar? No. Gradient of phi is what? It is a vector. It is a vector. Gradient of phi is a vector. Remember this. Gradient of phi is a vector point function. Again, if f is vector point function, then what you find out regarding this f? You don't find out the gradient of f, not gradient of the vector. You always find out gradient is defined for scalar point function. But when we find out the gradient of a scalar point function, it gets converted into vector. F is your vector point function. When you find out, you find here divergence of f. What is that? Del dot f. What is this? Remember, it is a scalar. Remember these things. It is a scalar. Now you find out curl of f. What is curl of f? It is del cross f. What is this? It is a vector. Now from these two things, we always find out divergence when f is a vector point function. We find out curl when f is a vector point function, but here we have seen our gradient is also a vector point function. Now we will develop new formulae. We will develop a systematic formulae, new formulae. Gradient of phi is our vector. Here we find out divergence of the vector. We find out curl of the vector. Similarly, now we will go for finding out divergence of gradient of phi. Curl of the gradient of phi. Why? Gradient of phi is itself a vector. So on the basis of this, when we form the divergence of vector, we find divergence of vector, of course, is a scalar. We find out curl of the vector. Similarly, we can find out divergence of gradient of phi, because gradient of phi is now vector, curl of the gradient of phi. Let us perform these results. How we go? On the basis of this, we find out divergence of gradient of phi. We find out curl of gradient of phi. I have not yet evaluated this, what this equal to. I am just telling you how we go, because this is our phi is our scalar, gradient of phi becomes vector, phi is our scalar, gradient of phi becomes vector. So we find out divergence of this vector, then curl of this vector. If we find out, what is this? When you find out divergence of gradient of phi, this means actually divergence is del dot gradient of phi. What is actually gradient of phi? It is your del dot del phi, gradient of phi. Then you find out curl of gradient of phi. This will be del cross, the character of curl is del cross grade of phi. What is this? Del cross again del phi. Again, when you have f a vector point function, when f is a vector point function, your f is vector point function, what is your divergence of f? It is, of course, del dot f. It is a scalar, but you don't find out the divergence of a scalar, you don't find out the curl of a scalar, but you find out the gradient of the scalar. So when your divergence of f is scalar, this means we can find out gradient of this scalar, divergence of f, because in future you may say how this comes, how that comes. It is the logic. I am giving you just logic and reason. We always find out gradient of the scalar, divergence of the scalar, divergence of the vector, curl of the vector. Do you follow? So this is gradient of the gradient of what? Divergence of f, because this is a scalar. So this is your del of divergence of f. This is your del operator of, this is del dot f. This is how we go. Similarly, you have when f is a vector point function, what is curl of f? You know it is a vector. Curl of f is a vector. In case of vector function, you find out what? You find out in case of vector point function, you find out it is divergence curl, not the gradient. So you find divergence of curl of f. What is this? It is del dot curl of f. It is del dot del cross f. Again, you have curl of f. Why so? Because curl of f is some vector. We can find out curl of a vector. So we sometimes find curl of f. So not curl of the divergence of f, because divergence of f is itself a scalar. We don't find curl of the divergence of f. Yes, so it is curl of f. This is del cross curl of f. What is this? Del cross f. So actually these are the things we have to find out. This is, in all such cases, we get the second order differential operators. When you repeat del dot del, when you write del dot del, when you write del cross del, it is a second order, because del dot del involves del operator dot del operator del square. Sometimes we write del 2, the pronunciation del 2, not del square, del 2, like this. You have del dot del, we write it del 2. You may read del square, but proper is del 2. Now I will give you the three fundamental results, very important results that we will prove now, and you will require those results in future course of this today in vectors, where we read these vectors in between some terms, in between some questions. There you can apply the result. Very important. These are known as three fundamental results on second order, these differential operators. We shall prove them, state and then prove. I wrote here three important results that we will prove here on this second order differential. Phi is, I took phi a scalar point function, f a vector point function. Then I will find out divergence of gradient of phi is this, del 2 phi by del x square, del 2 phi by del y square. Very important. You have to remember this. You will be using it in future. Wherever you come across divergence of gradient of some scalar point function, you can immediately use this result. Second, curl of the gradient of phi. Curl of gradient of phi is del cross del phi. Del cross del phi, it is 0. Remember this. And divergence of curl of f. F is your vector point function. It is also 0. Very important result, interesting results. Let us prove it. We have the proof of these results. Proof of first result. We have divergence of gradient of phi. You know it is equal del dot gradient of phi del phi. Well, the del has its own vectorial character. What is that? I dou by dou x plus unit vector j dou by dou y plus unit vector k dou by dou z. Then you know it is dot I times del phi by del x plus j times del phi by del y plus k times dou phi by dou z. Sometimes I read it del, actually it is dou partial derivative. I maybe miss this pronounce it. It is your del operator. This is your dou by dou x, dou by dou y, dou by dou z, dou f by dou x, dou f by dou y, dou phi by dou z, dou phi by dou y. This is your partial derivative. I have to prove these results now. I will write these here, what I have to prove next. I have to find curl of grade of phi. I have to find divergence of curl of f. I will write them there. Well, this is your now divergence of gradient of phi is equal to, it is I dou by dou x plus j dou by dou y plus k dou by dou z dot I dou f by dou x. When you perform the dot product, I dot I is 1 here, it is dot product performing, it will be dou by dou x of dou phi by dou x, then plus dou by dou y of dou phi by dou y, then plus dou by dou z of dou phi by dou z. Yes, dou z. What is this? It is dou 2 phi by dou x square plus dou 2 phi by dou y square plus dou 2 phi by dou z square. This we proved divergence of gradient of phi. This is your divergence of gradient of phi. This proves the first important result. Now let us go to second result. Proof of second. Second is proof of second result. You have to find out curl of gradient of phi. This is actually curl, you write it del cross gradient of phi. You can write it del cross gradient of phi, simply means del phi. And what is this del operator? It is your I dou by dou x plus j dou by dou y plus unit vector k dou by dou z. Then here I have cross, this is dou phi by I times dou phi by dou x plus j times dou phi by dou y plus k times dou phi by dou z. Now how you write down the cross product of two vectors? You did it in your vector calculus in lower classes, 12th class you did in cross product of two vectors. We can express them in the form of the determinant. First row you write ijk, second row components of the first vector, that is components of this vector, then third row will be components of this. So that means accordingly I can write this as cross product is, this is cross product, I can write, put it in the determinant form like this. This is your I j k determinant form, cross product. Then components of first vector, it is dou by dou x, here dou by dou y, here dou by dou z. Okay, Then components of this vector, coefficient of I, it is dou phi by dou x, it is dou phi by dou y, it is your dou phi by dou z. Now you evaluate this by determinant rule. We evaluate it by determinant rule. It is I times this with this, dou by dou y of what? Dou phi by dou z minus dou by dou z of, delete this row, this column, dou phi by dou phi by dou y, then minus j, delete the second row and second column, you delete second row and second column, it is dou by dou x of second row second column, sorry, first row, and you have to delete first row and second column, you are deleting first row second column, dou by dou y, dou phi by dou z, then minus dou by dou z, dou phi by dou x, then plus k, delete the first row and third column, it is dou by dou x, dou phi by dou y, minus dou by dou y, dou phi by dou x. Let us simplify this now. We simplify this now. This is I times dou 2 phi by dou y dou z minus dou 2 phi by dou z dou y. This is minus j times dou 2 phi by dou x dou z minus dou 2 phi by dou z dou x, then plus k times dou 2 phi by dou x dou y minus dou 2 phi by dou y dou x. You will be using this fact here, dou 2 f by dou x dou y is always dou 2 f by dou y dou x. That means this is equal to this. It is I times dou 2 phi by dou y dou z. This is again dou 2 phi by dou y dou z. Similarly, minus j times this plus k times this. This is equal to this. This is equal to this. So this is I times 0 plus minus j times 0 plus k times 0. So this is 0. Therefore, we have proved that this result is divergence of the gradient of phi is, this curl of the gradient of phi is 0. Curl of gradient of phi is 0. Thus we proved that here curl of gradient of phi is 0. This is the second very important result. You have to also remember this result. Now let us have the third very important result. Now proof of the third result we will go, where we have to find out this divergence of curl of f, but f is your vector point function. Next we find out this in third formula, divergence of curl of f. This is the third very important result. You will also remember these. Always to remember that whenever we find out curl of the gradient of phi, it is 0. Whenever we find out divergence of the curl of f, it is also 0. Let us have the proof of this. This is your actually del dot del cross f. How we go? Divergence means del dot curl of f, it is del cross f. We write for the time being, let fb is equal to f1i plus f2j plus f3k. We assumed this. Suppose f is some vector point function, I assumed it, let it be f1i, f2j, f3k. f1, f2, f3 are the components of this vector point function. These are the components. Now I will first find out this. What is my del cross f? It is your I dou by dou x plus j dou by dou y plus k dou by dou z cross f1i plus f2j plus f3k. This is equal to, it is I j k. First row we replace by I j k, and here we write the components of this first vector. It is dou by dou x, it is dou by dou y, it is dou by dou z. Then components of this is f1, f2, f3. Clear? Therefore I write dou cross f, del operator cross f, del operator cross f, it is I times, multiply this, it is dou f3 by dou y minus dou f2 by dou z. I am operating this determinant, then minus j times, delete this column and this row, it is dou f3 by dou x minus dou f1 by dou z, then plus k times unit vector k, it is dou f2 by dou x minus dou f1 by dou y. Let us have a look again. This is I, delete this row, this column, dou f3 by dou f2 z, minus j, delete this and this, dou f3 by dou x minus dou f1 by dou z, delete this column and this row, this is dou f2 by dou x, dou f1 by dou y. It is okay. Use this now in first. Using this result in first. I will be using it in first. Well, this is your, I will write the value of del operator. It is I dou by dou x, j dou by dou y plus k unit vector dou by dou z, then dot, use the value of this del operator cross f that I found here. It is I dou f3 by dou y minus dou f2 by dou z, then minus j dou f3 by dou x minus dou f1 by dou z plus k, it is dou f2 by dou x minus dou f1 by dou y. Well, dear students, I found this separately, del operator cross f, taking f any vector point function, then finding out the cross of that with f. Now I am operating dot in between these two. Let us operate dot in between these two. When I operate dot, I dot I, this is coefficient of this, in case of dot product, you know, is directly multiplied by this. It is dou by dou x of dou f3 by dou y minus dou f2 by dou z. Then this with this minus j minus dou by dou y of dou f3 by dou x minus dou f1 by dou z, then plus dou by dou z of dou f2 by dou x minus dou f1 by dou y. I am just using the dot product. In case of dot product, we simply multiply component of I with the component of I, component of j with the component of j, component of k with the component of k, as you know, in case of dot product. Well, this is now as usual dou 2 f3 by dou x dou y minus dou 2 f2 by dou x dou z. This is minus dou 2 f3, I am operating this differential, dou 2 y dou z, it is dou y dou z, dou y dou x, sorry, plus dou 2 f1 by dou y dou z plus dou 2 f2 by dou z dou x minus dou 2 f1 by dou z dou y. Let us make the groups. I will connect this with this one. It is this dou 2 f3 by dou x dou y minus dou 2 f3 by dou y dou x, then this group minus dou 2 f2 by dou x dou z with this plus dou 2 f2 by dou z dou x, connecting this with this, then finally plus dou 2 f1 by dou y dou z minus dou 2 f1 by dou z dou y. You see, this is equal to this, as you know, this quantity is equal to this. When this is equal to this, it is dou 2 f3 dou x dou y is equal to dou 2 this is equal to dou 2 f3 dou y dou x. So these become 0 because these are equal. This is equal to this becomes 0. So this is also 0. This is equal to this is also 0, and this is 0. Clear? So we have proved the very important results in this case. You will remember these results. Well, you have proved the very important results. Curl of gradient of phi, which you also write del cross del of phi, it is 0. Divergence of curl of f, which you write del dot del cross, it is dot del cross f, it is also 0. Remember these, we will be using these in future course of Excel. Divergence of, you did divergence of gradient of phi, you proved it dou 2 phi by dou x square plus dou 2 phi by dou y square plus dou 2 phi by dou z square. Later on we may be calling this Laplacian equation, but not yet. We will be calling this later on. These are three important results that we did in this lecture. Hope you have followed me, and you will revise this. This was lecture number 4th I have delivered, and wait for the next 5th lecture. And till then, you revise. Wish you a good luck. Happy days ahead. Thank you very much.